This is the study of unit rates. How do you know? So let's redo our number routine over our previous lesson over ratios. Remember, ratio is comparing two quantities or two items. For example, we have pens and pencils. Are there 2 times as many pens as pencils? We could look at a pictorial model. 2 pens for every pencil. 2 pens for every pencil. Pens for every pencil. I agree. Or you could do the comparison. There are 6 pens to 2 pens. Sorry, 6 pens to 3 pencils. 6 pens to 3 pencils. We could write it as in this type of ratio form, in fraction form. There are 6 pens to 3 pencils. If we simplify this by dividing the numerator and denominator by 3, it would be 2 pens for every 1 pencil. So I agree with this. There are 2 times as many pens as pencils. So we have a Fiat 500 and a Honda CRZ. The Fiat drives 272 miles with 8 gallons of gas, while the Honda drives 185 miles with 5 gallons of gas. Paul is in the market for a new car. He wants to buy a car that has great gas mileage. Which car should he buy and why? So this is a real life situation of what unit rate is or unit price. But since this is nothing hasn't to do with anything with money, we'll use unit rate. So what would you do here? If you just look at it, eyeball it, all right, if I double this, that'd be 10 gallons of gas, and that would be almost about 400 miles, a little less than 4, be 15 less. That would be about 370 miles with 10 gallons of gas. You know what? I need to do an apple to apple comparison. That means I need them to have the same number of gas so I can see compare the miles. How could I do that? Why don't I break this down? I'm going to break down 272 miles, 5-gallon gas, so I can find out how many miles I can drive with 1 gallon of gas. 8 goes into 0 times. 8 go into 27 3 times. You get 32. How many groups of 8 go into 32? 4 times. So I can drive 34 miles. So I broke it down. I broke these miles down into 8 groups. So I can drive 34 miles with 1 gallon of gas. Let's try this side. I can drive 185 miles with 5 gallons of gas. I want to break it down into individual gallons. Can 5 go in 1? 0 times. Can 5 go in 18? 3 times. What do you get when you subtract 18 and 15? You get 3. Bring down the 5. How many groups of 5 go in 35? 7 times. So I can drive 37 miles with 1 gallon gas, or 37 miles per gallon, or 37 miles for each gallon I put in the car. So that means I would recommend he buy the Honda CRZ because you can drive at 3 extra miles for every gallon of gas. If you say, well, it's only 3 miles, but think of how many in a lifetime of a car. That could be a lot. Like if they had 2 gallons of gas, that would be 74 miles with 2 gallons of gas, while this will only be 68 miles with 2 gallons of gas. So let's watch this video.
Bridge seal holding.
What's the damage?
Worry about that later. What's the relative velocity? 12 meters per second. Copy.
So I believe that comes from the movie The Martian. So astronaut Lewis talked about their relative velocity or speed as 12 meters per second. This is called unit rate. That means you broke it down for every unit, which is a second. How many meters can you do for each second? How many units can you do? How many meters can you do for 1 second? Or how many meters can we do per second? So the Max shuttle was going 60 meters in 5 seconds. Is that equivalent to 12 meters per second? Why? Let's look at this. So I'm going to set it up. I'm going to see if it is 60 m for meters in 5 seconds. How can I break this down per second for each second for 1 second? To break it down, I'm going to divide by 5. I'm going to divide the numerator and denominator by 5, and I get 12 meters for 1 second, or 12 meters per second, or 12 meters for each second. Another way you can think about it is a bar model. This is a bar model. We are going to be talking about this today. Imagine that this entire bar contains the 60 meters. We want to break this down into 5 groups, or 5 seconds. So how many meters will go in each section, or each second? 12 meters, 12 meters, 12 meters, 12 meters, and 12 meters. So 12 meters goes in for each second. So with this, you know that if it's 2 seconds, it'll be 24 meters, 3 seconds, 36 meters, and so on. So a rate is comparing two different quantities with different units, like meters and seconds, miles per gallon, many different ones. You eat number of hot dogs, like Joey Chestnut and the hot dog champ. He's hot dogs per minute, I think, or per second. So a unit rate is a rate that is written as a fraction so that it has a denominator of 1. When you usually say this, you always say the word per. Because per means like dollars per magazine, miles per hour, heartbeats per minute, and so on. Per means divide 1 unit. So for example, we have 15 characters. So someone types 15 characters in 5 seconds. That really means 3 characters in 1 second, or 3 characters for every second, or 3 characters per second. So we broke this down into 1 unit, which is the second. If it involves anything with money, like if you go to the store, a grocery store, Fiesta or HEB, and you buy like mangoes, and it's like 4 mangoes for $1. If I want to break it down, because I just want to buy 1 mango, how much would it cost? 25 cents per mango. 25 cents for each mango. 25 cents for 1 mango. So imagine someone's going to a movie theater. They spend $36.60 for 4 tickets. If I break it down per person, or for each person, or for 1 person, it's $9.15 for 1 ticket. So it's cost divided by unit. So unit price or unit cost is for 1 unit. So we're going to practice this with the bar model, like I said earlier from the Martian movie. A package of 6 crackers contains 246 calories. Blah, blah. How many calories are in 1 cracker? So this bar contains 246 calories. I would like to break it down into 6 crackers. 1, 2, 3, 4, 5, 6. So how many calories are there in each cracker? Per cracker. For 1 cracker. So, does that mean I'm going to have to divide it? Yes, it does. 246 divided by 6. Can 6 go into 0 times? Can 6 go in 24? 4 times. Bring down the 6. Can 6 go in 6? 1 time. So, there are 41 calories for each cracker. 41 calories for each cracker. 41 calories per cracker. 41 calories for one cracker. What if I want to eat 2 crackers? 41 plus 41, 82 crackers. What if I want to eat 4 crackers? 41, 41, 41, 41. That'd be 164 calories. So that's one way to do it. Some of you may look at this and say, I don't really want to draw a bar model. Fine. We can set it up as a rate. Comparison of 2 quantities with different units. So we have 246 calories. If I'm not mistaken, I think calorie is represented with the letter K, I think. Maybe nutritionist or dietitian will be able to correct me there. And 6 crackers. Make sure you label your numbers with units. No naked numbers, because you don't label it. You won't even know what these stand for. So 246 calories for 6 crackers. I want to find the number of calories for 1 cracker per cracker, for each cracker. That's called unit rate. I'm breaking it into 1 unit. So to break it down from 6 crackers to 1 cracker, I need to divide the numerator and denominator by 6. So I already did it up here. 246 divided by 6 is 41 calories for 1 cracker. 41 calories per cracker for each cracker. So a bottle of body wash costs $2.88. It contains 12 ounces. Find the unit price. How much does it cost per ounce? Each ounce for 1 ounce. So I need to break down this price into 12. 1, 2, 3, 4, 5, 6. All right, these are all supposed to be equal size. 7, 8, 9, 10, 11, 12. I apologize, but they are all. Oh, no. It's okay. It's okay. The power. Much better. The power of Smartboard. So, as you can tell, so we have 12 seconds. So I need to break it down into 12 sections. So, is that just really dividing here? So let's get it. So I'm dividing $2.88 into 12 sections because there are 12 ounces. So I'm going to know how it costs per ounce, each ounce for 1 ounce. Can 12 go into 2? No. Can 12 go into 28? 2 times. So forget the decimal point. So if I subtract 28 minus 24 is 4. I bring down the 8. How many 12s go in 48? 4 times. So it costs 24 cents for each ounce. 24 cents per ounce. 24 cents for 1 ounce. I'm not going to repeat this, but imagine all this bar model is filled with 24. So using this bar model, what if I want to have 2 ounces? 24 plus 20 is 48 ounces. What if my bottle, in traveling, I just came back from my trips, you're only allowed to bring a 3 ounce. I think it has to be less than 3.4 ounces when you ride an airplane in your bag. So 24, that would be 72. Let's see, 4, 8, 12, 31. Yep, 72 cents for 3 ounce. What if you're looking at this bar model and say, I don't really want to do a bar model? Fine. So it's $2, and I'm going to set it up as a rate. $2.88 for 12 ounces. I need to break it down to 1 ounce because it says per ounce, each ounce. So to break down 12 ounce to 1 ounce, we divide by 12. 2.88 divided by 12, we just did it earlier. It is 24 cents for 1 ounce, 24 cents per ounce, 24 ounce for each ounce. Travis drove 130 5/10 or 130.5 miles in 3 hours. He drove at a constant speed. How many miles did he drive per hour? Each hour, 1 hour. So I need to break this down into 3 groups. So I need to find how many miles for each hour. So as I look at my bar model, I have to divide this. How many 3's go into 13? 4 times. Because 3 doesn't go into 1, so that's why I just skip that. How many 3's go into 10? 3 times. That's 9. You have a remainder of 1. Bring down the 5. Don't forget that decimal point. Line them up. How many 3's go in 15? 5 times. So it's 43.5 or 43 and 5/10 or 43.5 miles for each hour. Per hour for 1 hour. What if I wanted to drive for 2 hours? Let's see, 43.5, that'd be 86, half and half, 87 miles in 2 hours. What if you're looking at this bar model and say, you know what, I'm not doing a bar model. I'd rather set up as a rate. So 130 and 5/10 mile, make sure you label it. Rate, you got to label it. 3 hours. Do you notice how when you did ratio, you didn't label the units? But in rates, you do. So I need to break it down to 1 hour. How am I going to break down 3 hours to 1 hour? I need to divide a numerator and denominator by what? 3. And you see I did it up here earlier. So the answer is 43 and 5/10 miles per hour for each hour for 1 hour. So Craig swam 18 laps, 18L, in 30 minutes. He swam at a constant speed. How many laps did he swim per minute, for each minute? So I will have to break this up into 30 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again, I'm not doing a really good job here. It's supposed to be equally spaced. 3, 24, 25, 26, 27, 28, 29, 30. So let's make a prediction here. Can he do 1 lap per minute for each minute? Will the answer be more than 1 lap? 1 lap or less than 1 lap? If he can only do 18 laps in 30 minutes, well, he can't do more laps per minute. So I know the answer is going to be less than 1. I mean, look at it. You have 18. You're dividing it into 30 sections. So we know our answer will be less than 1. So 18 divided by 30 sections. Can 30 go in 18? I don't think so. 0 times. What do I do? I'm stuck. That's it. I'm done. Oh, I put a little r. No, you don't. That's elementary school. Remember, you put a point. I need 0 because I don't want to change the value of 18. So that's why I had to put a 0.0, a placeholder there. So I bring it down. How many 30s go in 180? 6 times. So he can do 0 and 6/10 or 3/5, 6/10 or 3/5 laps per minute for each minute, for 1 minute. So if you do not like the bar model, I like the bar model. But some people will look at this, some of your parents may say this, I'm not doing it that way. That's like voodoo math. No, it's not. It's showing the pictorial. To each our own. So 18 laps, 30 minutes. I need to break it down to 1 minute. So how do I break down 30 minutes to 1 minute? I divided numerator and denominator by 30. And I did it earlier. So it is 6/10 laps per minute for each minute for 1 minute. So that is so far what we've learned so far. So in this one, so why do we also need to know unit rate or unit price? So we saw it with the car thingy. Another reason is because when you go to the grocery store, did you know in the grocery stores, if you look at the price tags really closely, they always show the unit price, how much it costs per ounce. Because I know when I go to Costco, and I buy stuff, I always like saying, is Costco really much cheaper than our HEB or something? So Mrs. Meyer wants to buy some peanut butter for her girls. She has 2 daughters. She wants to buy as much peanut butter as possible. Which brand is the better buy? Justify your answers. So Jif costs $2.22 for 12 ounces. Skippy costs $2.70 for 18 ounces. And Peter Pan costs $4.62 for 28 ounces. So what should we do here? Well, first of all, is this an apple-to-apple comparison? No, because they all have different number of ounces. They're all different, packaged differently. So we need to figure out how much it costs for the same number of ounce. So unit price per ounce for 1 ounce for each ounce. So if you divide 220, so on your own, I'm not going to do this on the video, but you need to divide $2.22 by 12. You need to break it down. Think of a bar model. You have $2.22, and you break it down to 12 sections. How much would it cost per section, per ounce? Think of a bar model. You have $2.70. You got to break it down into 18 ounces or 18 sections. How much will it cost for each section? Or you may just look at this and say, I don't like the bar model. Fine. You have $4.62, and you have to break it down into 28 ounces. Sorry, it costs $4.62 for 28 ounces. I need to break it down to 1 ounce. How am I going to break down 28 ounce to 1 ounce? I divide both numbers by 28, and you get an answer. And I do not have the answer. So, and so on. So what we talked about was unit rate and unit price. Unit rate and unit price is breaking things down into 1 unit per unit for each unit. And that's how you can tell. And then you can build it up using a ratio table, which is our next our lessons start coming up soon of it. Thank you very much.